In this lesson, we're going to take a look at how the universe may have formed. The Big Bang Theory explains how the universe formed from a single point. And there's lots of evidence that supports the Big Bang Theory. Basically, the Big Bang Theory says everything used to be all together in one spot. That spot exploded and has been expanding ever since, and that has led to the rise of the universe. This single point that it was contained in is sometimes referred to as the singularity or a singularity. Everything was all together in one spot. And it was infinitely dense, and it had very, very extreme infinite temperatures going on in there. So it was hot, it was dense, everything was there. And then it expanded. It expanded very, very, very rapidly. And that expansion led to cooling, and that cooling allowed particles to form. And as these particles formed, lots of different things happened, lots of physics occurred, and actually there's several particle accelerators that try to recreate what happened near the beginning of the Big Bang to try to figure out exactly what was going on. We're not going to get into all of that science, but basically the Big Bang Theory says the universe has been expanding from that point for the last 13.8 billion years ago, billion years or so. Evidence supporting the Big Bang includes that we can actually observe the universe expanding. The universe is cooling down. There's background radiation. These two kind of go together. And the elements that we see that the universe is made out of are all the lighter elements. It's mostly hydrogen and helium and a little bit of lithium. There's not very many heavier elements in the universe. And the Big Bang Theory is able to explain why things are the way they are. So the ones I want to take a look at in more depth are the expanding universe. How do we know the universe is expanding? What can we do to measure this? Well, it turns out we can look at galaxies. We use telescopes to look at galaxies, but not only that, we look at the light the galaxies emit. So in 1929, Edwin Hubble, who the Hubble Space Telescope is named after, he observed that galaxies are drifting apart at high speeds. And what he did was he noticed that the spectrum of light emitted from galaxies tended towards the red side of the spectrum. Now, to understand what that means, we have to understand that light is actually waves. And the different colors of light are due to different wavelengths. And you guys are familiar with the rainbow: red, orange, yellow, green, blue, indigo, violet. Okay, the reason the rainbow colors go in that order is because red waves are very, very long and violet waves are very, very short. Okay, these ones have low energy. These ones have high energy. Okay? Now, if you think about a wave is emitted from a source and it travels. Okay? And if you happen to be traveling this direction, you're going to run into each one of these waves sooner than if you had been standing still. That's going to make it seem like these waves are getting closer together, or they're actually shorter than they are. That's going to make these waves appear more blue. Whereas if you were moving with the wave, so the wave is moving this way and it's got to catch up to you, each one of these is going to be a little bit further behind than it should be, and that's going to make the wave seem longer or more red. So shortest waves are blue because, and that's the way our eyes interpret wavelength or frequency of the wave. The shorter the wave, the bluer it looks. The longest waves are red, the least energy, and motion relative to these things causes the waves to either be squished, making the wave appear shorter and bluer, or the motion away from you makes it stretched, and that makes the wave appear longer and redder. What Hubble observed was that galaxies shifted towards red, which means they're moving away from us, or we're moving away from them. Either way, we're not getting closer together. Not only that, he noticed that the ones that are furthest away are moving the fastest, which isn't surprising, but that means if you extrapolate back everything, the ones that are furthest away are further away because they're moving faster. That means everything used to be closer. Everything used to be in the same general region of the universe. So it's now expanding to fill this space. It used to fill this space. It used to fill this space. You can extrapolate back to a point where it all existed. And so the red shift is major evidence, because the universe is expanding, that it used to be closer together. The other thing we have to pay attention to is background radiation. The Big Bang Theory basically says everything used to be contained in one spot, and it's been expanding ever since. Now, most of this stuff that was here is energy, right? When this first started, it was extreme energy, heat, infinitely dense, whatever. Shortly after this expansion, the whole universe is contained in a very small spot, and there's energy throughout that. And that energy, remember, energy is not matter. It's not really affected by gravity like matter. And so this energy that's left is going to continue to be able to move through the expanding universe fairly uniformly. Now, as the universe gets bigger and bigger and bigger, that energy has to keep spreading out, and it keeps spreading out, but it gets less and less and less and less and less and less prevalent because the universe is larger. The same amount of energy can't fill it up as much, and so this causes cooling, right? This energy spreading out, everything gets cooler. But the Big Bang Theory predicted that we should be able to measure or detect this energy out in the universe, and it should be fairly uniform everywhere. And we actually found it. We found it accidentally. There were some guys in the 1940s who were doing some radio telescope measurements, and they built this big detector, and they turned it on, and then they started getting this static, and they were like, oh geez, our huge experiment doesn't work, and they couldn't get rid of it. It took them a while, but they finally figured out, oh, well, it's not that our detector is not working, it's that it's detecting this background radiation. So the background radiation is this leftover energy from when the Big Bang occurred, and this is actually a map of it. I think they spent 8 or 9 years using radio telescopes to look at the entire sky, and they mapped out the background radiation. And you can see it is fairly uniform. There are seeds of it where there's a little bit more energy. There's seeds where there's a little bit less. But this background radiation was predicted to exist by the Big Bang Theory, and then it was actually found accidentally after it had been predicted. So that's a pretty big indicator that, yeah, the Big Bang Theory can explain a lot of how the universe came to be.